Hello and welcome to a little showcase that I'm going to give you about my portfolio website, which is itself part of my portfolio, which is kind of funny. So first of all, I'm just going to list the technologies that I use to create it, and then I'll go more in depth into each specific service associated with the portfolio website, just so you can sort of get a grasp of it. I'm just going to separate things into three categories. So, backend, front end, and infrastructure. And I appreciate these things are not lined up very well. I can just move them, I think. Yep. Okay, so for the backend, I used Rust. Now, obviously, it doesn't usually make sense to use Rust for such a small project that doesn't require so much performance. But it was mainly used as a showcase of my capabilities. For the front end, I used JavaScript/TypeScript, and it doesn't fit, but you get the gist. With React, and for the infrastructure, it all runs on a VPS. And on that VPS, we have a production Kubernetes. I'm going to use this keyboard. Sorry, Kubernetes cluster, which I spun up and sort of templated using Helm. I don't know if you're familiar with it, and Helm file, basically allowing me to specify pretty simply through templating the different parameters needed for different environments, and it allows me to spin up the clusters on both environments literally with one command, which is great. So that's a brief overview of the technologies that I used for each of the front end, back end, and the infrastructure. Now I'm going to sort of go into each one a little bit more. So let's have a little looky here. So this is the website itself. So I'm just going to give you a little look at the front end. You've probably already seen it, but this is the current state of things. Now it's as I said before, a React app. I'm going to inspect element here and show you that it is indeed responsive, meaning that it works for all screen sizes pretty much. I did it from small mobiles to 4K. That's what it's been tested on, and beyond. And you can see the elements change depending on the screen size. Got some nice animations as well. Yeah, it's a fairly simple single page application. So let's dive a little bit into the code here. So this is the wrong repository. So I do apologize. It's quite a raw recording here, and I've made everything big. I don't usually code this big, just so you guys can see it a little bit. So the technologies that we use here, as I said before, is React. We bundle it all with Vite. So let's have a look at the package JSON. See what we've got here. I use Vite. A lot of people use Webpack, but I find that let me just delete everything here. A lot of people tend to use Webpack, but I find that it can be quite slow. It's quite annoying to configure. Vite's actually really quite simple, quick, and it also comes with a testing framework. So a lot of people use Jest for testing. Vite uses Vitest, which is literally essentially like a fork of Jest. It's like the exact same syntax, but it just integrates nicely. And this is all done in TypeScript as well. As you can see, all TypeScript files, all these squiggly lines are just because I don't actually develop on this machine. So I actually haven't installed things. I probably just have to run yarn, and it will install everything, and it'll be fine. The squiggles will go away. This is just, I've just got a nicer screen here so I can record better. So yep, let me just look at my little notes on the things I wanted to talk about. Yes, so as you can see, okay, don't worry about that. I don't actually develop on this machine. So let's go to some of the pages. Let's go to the contact form, for example. You see we use React hooks. So this is modern React. Obviously React hooks been out for a while now, but we call it. So it's not so modern, but I was there at the days before React hooks as well. So I'm familiar with both, but using React hooks here, we do actually have Redux installed, but we don't actually really use it here. But it's it's just there for showcase, but it's not really needed in this application. And I use let's have a look at some of the styles.ts here. I use styled components, or a version of styled components, like basically another fork of styled components that works with Vite. So emotion style, this is the exact same as styled components, to style all of the React components that outputs actual React components that have been styled with the CSS that you provide it, and that allows dynamic styling and things like that. And it also integrates very nicely with a bunch of other frameworks, like frameworks that are used for animation and stuff like that. And you can see a bunch of media queries here, which is actually this is actually a function that generates all of the media queries for different specific screen sizes and saves a lot of unnecessary verbose code. But we got a bunch of media queries that allow this to be a very responsive website for different screen sizes. So that's a little look at the code for the front end and stuff like that. Obviously, these repositories are all public, so you can look at these in full detail. This is just a little tiny showcase. If you really wished, you could see it in full detail, and in the future I might actually change this sort of stuff. So if this is outdated, then you can just go ahead and check things there. And obviously I've showed you this. So yeah, let's have a little look at the back end. Hopefully my face is not is not blocking anything on the screen. Okay, let's move this over here, and let's go to the back end. Okay, so the back end is all developed in Rust, and as I said before, probably not needed for this, but it's a bit of a showcase of my skills. I did some Rust in when I worked for Passport, and I learned it on the job. Actually, it's not something that I really had a lot of hands-on experience with before, but I was up and running with it fairly quickly, which I guess showcases like some level of adaptability there as well. So yeah, what I've actually done with this Rust backend, I haven't actually used an existing HTTP library. I've actually gone and made my own. So let's quickly have a little look at things. Let's go into the server.rs, and you can see this is where you define your HTTP server. What we actually do is we use a TCP listener. Where is it? Up here. And we listen for incoming TCP requests. We then read that buffer and convert it to UTF-8, pass that as a HTTP request, and then we respond accordingly. This is actually done using Tokyo, which Tokyo for Rust is, so if you're familiar with JavaScript, asynchronous programming, async await and that sort of thing. Rust actually sort of has that too, but Rust requires, so let me go to the, actually I'll use this thing again. Rust requires an async runtime, which is essentially something. So async await in Rust is lazy, which means the functions that you define as async don't actually run when you call them like this. They only run when you poll them, which you can do with await as well, kind of. So when basically an asynchronous runtime, which one for Rust is called Tokyo, what it does is it handles when we poll these specific asynchronous functions. So we use Tokyo here to handle all of that. As you can see in the, that's not the right file, Tokyo. And so this TCP server, this HTTP server that I've defined here, as you can see, uses Tokyo to spawn a bunch of tasks. These tasks are asynchronous tasks, and they run on multiple threads. So this is actually asynchronous and multi-threaded Rust, which can be a bit nuanced. It's quite tricky. We have to have atomic reference counters and mutexes in multiple places to ensure that that only one thing at a time is accessing data that's shared, and that the lifetime of that data is longer than the task, so that it's longer or equal to the task, so that that data still exists. The HTTP server that I've created here as well allows like pretty common things that you see in some of the other popular HTTP server libraries, such as those that you might be familiar with in Node, like Express. So we've got routes that you can define. Let me show you an example. I can send email. I've defined a route here. I should go to main.js. I don't develop in this environment, so I haven't installed the dependencies, so it's doing this. But you can define the route here, and that's associated with this particular handler, which we can see over here, which has this particular logic, which you can define easily using this macro that I created. Simplifies some of the syntax, but it has similar capabilities to some things that you might be familiar with, like Express or Node.js, where you can define those routes, and it will pass it with a closure, which will pass in the request and the response. You can make these mutable if you want, so that you don't necessarily have to respond with this, and it'll continue on to the next route and the next route that matches, and you can respond at any point. Same with the middleware. So we actually have a cause middleware here. You can add middleware to the HTTP server, which deals with any options request that comes in, and does all of the necessary cause stuff to do with that. Basically, this sometimes modifies the response object before it's actually returned. So we have the capability to do that in this HTTP server that I've created. You can go ahead and look at this more in the public repo if you desire. But yeah, it's a tiny little, it's a sweet little library that I created just for the purpose of this, to sort of showcase. But yeah, in this actual project, all that we actually necessarily do, all we actually need it for, is the sending of the emails. So in the contact form, if you put in something into contact form, you'll see that both you and I will get an email. And then I will try and get back to you as soon as possible. But yeah, that's the Rust backend. I'm just going to check, but I don't think there's anything else I need to say about that. Yep. So onto the infrastructure. So let me just go over to here. We already have it open. So the infrastructure, as I've said to you before, is done in. I'm just going to draw it on. In Kubernetes, or K8s, some people say, well, it actually is hosted on a VPS, but I've worked with things like AWS and GCP before. That's not a problem. But and I've set up GitHub Actions in all of the repositories to automatically, build the Docker images and push out to the production cluster. And the GitHub Actions for the actual infrastructure repository, what it does is it updates the cluster with any of the new Kubernetes manifests. So it's all automated. Anything that's pushed to main is automatically live, which is great. So yeah, I use Helm file and Helm to manage the manifests / charts, you call it in Helm. And you can see in Helm file here, we defined the order at which we have to deploy each of those charts so that the cluster actually works, because a lot of the time in the clusters you need to define things in a certain order, because some things have dependencies. For example, some of your applications might require config maps or secrets that exist to exist before that you actually go ahead and start those deployments / pods or whatever, otherwise they'll just error out. So we've defined the ordering here. First of all, we need to deploy our CNI, configure container network interface. I think it stands for Calico. We use Calico here, which sets up all like the virtual networking and stuff like that for for the cluster. Then Cert Manager and Trust Manager, they're kind of together. I think they're made by the same people to sort of manage the issuing of certificates within your cluster. In production, it connects to Let's Encrypt. I don't know if you're familiar with them. Let me just get them up. And they're like a free service for issuing certificates to people. This is so Cert Manager basically handles all of that. It kind of links to Ingress Nginx, which obviously requires them to, which handles all of the ingress into the cluster. So if anybody makes a request to one of the services in the cluster, it goes through Ingress Nginx, which sort of routes the request to whatever the specific service it needs to be routed to. So for example, if I'm making a request to www.kblue.io, it's going to route that request to the pod associated with the front end. And if I do api.kblue.io, it will route to the Rust backend. So this is handled by that, and it also handles basically telling Cert Manager, for these endpoints, we need you to issue us certificates. And the cluster config, that's just a bunch of specific to this cluster configuration things to do with Cert Manager and other random stuff. The app, which requires everything else, the last thing we do is the app itself has the front end. So look at the charts here, the back end, the front end, and Postgres, which we actually don't really need, but I've just done it just in case we needed it, which right now, because we're running on a VPS, actually stores the data if it's prod here, and if it's in the dev environment, just in the repo. So yeah, that's the infrastructure. So, you know, if you have any more questions about this, feel free to reach me via the contact form. And you can see all of this source code live on GitHub. It's all public. And you can see all of this stuff in more detail. So yeah, thanks for watching. I also forgot to say one last thing. I don't know if I'm going to be able to attach this via YouTube onto the end of the video, but we shall see. This thing uses, the infrastructure uses something called Tilt for development environment, which basically allows me to monitor, and it basically attaches to the cluster locally, and allows you to monitor all of the services that you've configured it to. So I've configured it for the front end, back end, Postgres. You can see all the logs, and you can run some commands that you've set it up to do pretty easily through UI items, like restarting the pods, syncing local files, blah blah blah, reinstalling dependencies. And what's great about it as well is that it allows you to automatically sync files in your development environment, so that you'll get to update your services live. So it's a quick feedback loop, quick sort of development loop for your services, while still being able to run them in the environment that they will almost run in production, which is great. So yeah, that's just another little thing I forgot to add. I just wanted to add it in there.